Hey kids, Smath here. Got a video solution for you for AP Classroom free response question number 4. Now this is just a really long titration question. And I know you're saying, but Smath, titrations may not be on it this year. As a matter of fact, they're not going to be on it this year. But a lot of this question is stoichiometry and not necessarily titration. So it's still a pretty valid question. And I like it because of the reading that's involved. So let's go through step by step like we always do and give you an answer to each one with a good rationale, okay? So students given the task of titrating 20 mils of 0.1 HCl. So we got 20 mils, 0.1 HCl with 0.1 NaOH. Okay, the HCl is placed in an Erlenmeyer flask. Erlenmeyer flask. So that's the one that gets titrated into. Okay, so we got the HCl down here. Probably going to add a little bit of phenolphthalein to that, PTH. Phenolphthalein gets added to that, I bet. Okay, and the equation occurs. In A, they say, according to the equation, if the amount of the reactants is halved, how does that affect the H2O? Well, since the ratio is 1 HCl, 1 NaOH, 1 H2O, then it would have the amount of H2O. Period. Doesn't ask for why, doesn't ask for a justification, nothing going on there. Just tell them what happens to the amount. Well, it's cut in half. Okay. Then it says in B, hey, that's not net ionic. Could you write me a net ionic reaction? Boy, we could be so lucky. Would love to. How about H plus aqueous plus OH minus aqueous forms H2O, and in this case, a liquid. It didn't ask for states of matter, but I think in the correct form, net ionic equations really should have a state of matter associated with them. So let's give it to them. In C, in the equation you wrote in B, which one's the proton acceptor? Well, the proton right there, that's the proton. So your answer is OH minus. They don't ask why, they don't ask what, and they didn't use the term Lewis acid, Lewis base. They're sticking to proton acceptor. That's a fair game question, I think. You know, how many moles of HCl are in 20 mils of a 10th molar HCl? Once again, you guys, you're thinking, this is so easy. And it is. The chemistry's easy. We've learned a lot of chemistry. So just give them the answer they want. So take the 0.020 liters, 0.10 of a mole per liter, 0.002 moles of HCl. So far, nothing really too difficult. Now we're going to get to some curves. Now this is the part where we probably do digress. This will not be on your exam. This is a titration curve, but let's answer it still. Just for grins and giggles, it says place an X at the equivalence point, and we're going to go right up here and say, this is a strong acid, strong base. Put it right there on the X because this should be happening right at pH of 7. Right? In the box below, to the left represents ions of certain volume of HCl. In the box to the right, draw a representation if you doubled your concentration. Still okay. Double it up. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7. I don't know. Doesn't seem like there's much chemistry there. Looks like artwork to me. Okay, I think this is really very easy. But I really, really like this next question. G, on the graph in part D, carefully draw a curve for a second titration where 20 mils of 0.20 is with 10 mils of the NaOH, okay? So I'm gonna come back, and now we're gonna start at 1, come out, and mimic, and my equivalence point is still at 7, but my equivalence is happening out at about 40. How come double the volume? Because they doubled the HCl, so it's going to take me double the volume of the NaOH to get there. That's a really good question. Not going to be on your exam, but I do still really like that. And then in H, a student made an observation that the Erlenmeyer, how would you know that a chemical change took place from the Erlenmeyer flask? I got 2 things for you here. The first one is it's either going to get warm, it's going to have a temperature change, or it's going to change color with an indicator. So if we added phenolphthalein to this, we would say the HCl turned pink at the equivalence point. So a little bit acid-base, but a whole lot of solution, stoichiometry, a little bit of drawing, it never hurts. All the stuff that I think you're going to see on this year's AP exam. I'm Smath. I hope this video helped.